In this lecture, we will learn about the basics of working with numPy for data science. NumPy stands for Numerical Python. It provides support for multi-dimensional arrays of objects and various tools to work with them. Matplotlib, the Python library that we will learn about in the second half of this section, is built on top of the NumPy library. Before we can start working with NumPy, we need to first install it using a pip command. We will open up the command prompt or terminal program on our computer and cd into the directory where our Python file is located. Then we will type pip install numpy in order to install NumPy. Once this module finishes installing on our computer, we are ready to jump to PyCharm and start coding. Up at the top of the code, we will type import numpy as np. NumPy gives us a new data type we can work with, known as the nd array or n-dimensional array. They store elements of the same type and size. You may be asking yourself why use nd arrays when Python already has the built-in list collection type. The answer is that Python lists are pointers that have a lot of memory and computation overhead. Let's learn how to create an nd array using NumPy. We will create a variable named npArray, and we will set it equal to np.array with a list of the values 2, 4, 8, 16, and 32. Then we will print out npArray, and also print out the type of npArray. When we run the code, you will notice that an nd array with the values we specified was created, and that Python recognizes this data type as a member of the numpy.ndArray class. NumPy makes it easy for us to create arrays out of just zeros, which is something that comes up in data science pretty frequently. To do this, we use the zeros function. For example, let's create a variable named zerosArray and set it equal to np.zeros and pass in 5. The value we pass in is the length of the array we want to create. Then we will print out zerosArray. When we run the code, notice that an array with 5 zeros was created. Similar to the zeros function, the ones function allows us to create an array with all ones, which is another thing that comes up frequently in data science. For example, let's create a variable named onesArray, which we set equal to np.ones with the value of 5 passed in as the length. Then we will print onesArray using Python's print function. When we run the code, notice that an array with 5 ones was created. Another very powerful feature of NumPy is the ability to create an array with elements within a range of values using the arrange function. For example, let's create a variable named range 0 to 100 array, which we set equal to np.arrange and pass in 0 as the first argument and 100 as the second argument. Then we will print out range 0 to 100 array. When we run the code, notice that our array was populated with the values 0 through 99. This is because the 100 is excluded. If we want it added, we would have to specify an end value of 101. There is a third parameter that the arrange function accepts, which is the step value. Let's say we want it to go by 2s. We will have a variable named range 0 to 100 array by 2s, which we set equal to np.arrange, and pass in 0 as the first argument, 100 as the second argument, and 2 as the third argument. Then we will print out range 0 to 100 array by 2s. When we run the code, you will notice that the numbers go from 0 to 98 by increments of 2. This is just a taste of the power of NumPy. We will continue to get exposure to this awesome Python library in this section, and later in the course as other packages, like Matplotlib and some of the image manipulation libraries, depend on Python's NumPy library. In the next lecture, we will learn what Matplotlib is.